Hi everyone, let's work on inverse values and general solutions together. Before starting the lesson, we need to review this. All smarties take calculus. This means all the functions, all the trig functions in the first quadrant are positive. Only sine is positive in the second quadrant. Only tangent is positive in the third one, and only cosine is positive in the fourth quadrant. We're going to use this a lot throughout the lesson today. We're all familiar with sine of 30 equal to 1 over 2. If I want to undo a trig function like sine, I need to use inverse function like sine -1 or arc sine. So I'm going to take the sine -1 of both sides. I need to apply that for both sides, and if I apply that for the left side, these two are canceling each other, and I'm going to have only 30 degrees on the left side. And the right side will be sine -1 of 1 over 2. So this means the answer of sine -1 of 1 over 2 is equal to an angle. So whenever you see an inverse function, that is basically an angle measure. An angle measure. Now let's work on this example. Cosine -1 of 1 over 2. This means there is an angle that cosine of that angle is equal to 1 over 2. We're looking for this angle. Well, to solve this, I'm going to consider cosine is a positive value. That means the angle was either on the first quadrant, because here cosine is positive, or in the fourth quadrant. So the terminal side of the angle is going to be either here or the other one. I'm going to work on this first. So if this is the terminal side of my angle, the reference angle is going to be the distance between the terminal side and the x-axis. So it's here. I can make a right triangle using my reference angle and the x-axis. So we know that cosine is adjacent over hypotenuse. So I can match these together. Adjacent side of this angle is 1 and hypotenuse is 2. So I match them. Now I'm going to use Pythagorean theorem to find the other side. If you use Pythagorean theorem, you will see that this side is √3. Now the ratio of the sides on this triangle look familiar for me. This is basically the ratio of the sides of a special right triangle of 30, 60, 90 triangle. So the side which is opposite 60 is radical 3. So that means this side is 60. Opposite 30 is 1. So this angle here is 30. And opposite 90 is 2. So this angle is 60 degrees, or because we are working in radian, I'm going to call that pi over 3. Instead of 60, I write pi over 3. So I found the measure of the reference angle. Now, what is my original angle? If this is my reference angle, the original is going to be starting from here and ending at the terminal side. So it's basically the same thing as we have as a reference angle. So we have one of the answers ready here. Answer number 1 is pi over 3. That's the first answer. The second one, we said that cosine is also positive on the fourth quadrant. So here also we have another terminal side, another angle at the terminal side is here. Now again, I'm going to look for the reference angle first, terminal side and the x-axis, and then I make my right triangle. Then the ratio of the sides of this angle, adjacent is 1, hypotenuse is 2. Again, use Pythagorean theorem. This side will be radical 3. However, this one is negative because it's below the x-axis, so I don't forget about the negative. Now, again, the ratio of the sides of the special right triangle of 30, 60, 90 can be seen here. So opposite radical 3 is 60, or pi over 3. So I found my reference angle. Now, what is my original angle? The original is going to be here from start from the x-axis and ends at the terminal side. So what is the measure of the angle from here to here? In order to find that, the easiest way is to consider that if we had a full circle and we subtract pi/3 from that, that's going to be the distance from here to this point. So the second answer is 2 pi minus pi/3. You subtract pi/3 from the full circle. Now I'm going to take the common denominator. Denominator is 1, multiply by 3, both sides, top and the bottom by 3. It will be 6 pi over 3 minus pi over 3. And it's 5 pi over 3. So this is the answer. So we had two answers. One is this one and the other one is here. Now let's work on this example. Arc sine of -1 over radical 2. Sine is a negative value here. And sine is negative on the third quadrant and the fourth quadrant. So my angle should be either here or here. Let's work on this one first. If this is the terminal side, the reference angle is going to be this one. And here I have my right triangle. Sine is opposite over hypotenuse. So opposite is 1. Opposite of this angle is 1 and hypotenuse is √2. But how about the negative? The negative will go for this opposite side because we know that hypotenuse is always positive. And also it makes sense because this is below the x-axis, so this is negative. Again, if we use Pythagorean theorem, we're going to see that this side is 1. And it's negative because it's on the left side of the x-axis. Now we see the special right triangle of 45, 45, 90 here because these are the ratio of the sides 1, 1 and radical 2. So that means opposite ones are 45 degrees, or in other words, in radian, it's equal to pi over 4. So I found the reference angle. Now, what is the original angle? Start from the x-axis and end here. Okay, so what is the measure? You can take the pi from here to this side and add pi over 4 to that. So one of the answers is pi plus pi over 4. So I'm going to write this as pi over 1 and then find a common denominator. It will be 4 pi over 4 plus pi over 4. It's 5 pi over 4. The other answer is this one. Sine is negative in the fourth quadrant as well. So here's my reference angle, and this is the right triangle. Ratio of the sides opposite of this side is 1, hypotenuse is √2. Negative goes for the 1, and use the Pythagorean theorem to find this side. This time it's 1. Again, I see the special right triangle of 45, 45, 90. So this side, which is opposite 1, is 45 degrees or pi over 4 radians. Okay, now again, I found my reference angle. Now I can find my original angle. Start from the x-axis, positive side of the x-axis, and then go this way and stop at this point. So what is the measure of the angle from here to this point? The easiest way is take the full circle and subtract pi over 4 from that. So it's 2 pi minus pi over 4. Again, set the denominator of 1, multiply top and the bottom by 4. It's 8 pi over 4 minus pi over 4, which is 7 pi over 4. So these are the two answers. Now let's work on this one. Cosine -1 of negative radical 2 over 2. Cosine is negative. That means my angle is going to be either here or on this side. So let's consider this one first. Reference angle, my triangle here, ratio of the sides. cosine is adjacent over hypotenuse. So adjacent side is radical 2, adjacent of this is radical 2, and hypotenuse is 2. The negative goes for the adjacent side because we know hypotenuse is always positive. Use the Pythagorean theorem and you will see that the other side is equal to radical 2. Now the ratio of the sides are not really familiar for us. We need to make some changes. How about dividing everything by radical 2 here in this case? Divide everything by radical 2. Well, radical 2 divided by itself is equal to 1. So this side is basically 1. Negative radical 2 over 2, that's going to be equal to negative 1. And 2 over radical 2, we know that 2 is basically radical 2 times itself. Radical 2 times radical 2. And we had a radical 2 in the denominator. These two cancel each other and we're going to left with only 1 radical 2. So this side is radical 2. So we change the ratio of the sides in this way, which is more familiar with us. This is again 45, 45, 90. So this side, which is 1, is opposite 45 angle, 45 degrees angle, or pi over 4 radian. Okay, so again, we found the reference angle. Now the original angle is going to be this one. So first angle is, to find this distance, I can take the whole half circle, which is pi, and subtract pi over 4. Then I can find this distance. So pi minus pi over 4. This will be 4 pi over 4 minus pi over 4, which is 3 pi over 4. Okay. Now let's go to the next one. The next angle could be on this side, because cosine is also negative here. Now the reference angle is going to be this one, and then this is my triangle. Once again, I can find the ratio of the sides. Adjacent is radical 2, so I'm going to erase this. Is radical 2. And I'm going to put the negative for this one, and hypotenuse is 2. And we can use the Pythagorean theorem to find this other side as well. Again, the same story. I'm going to divide everything by radical 2. And I will see that the ratio are going to be like the one that we saw here. So they're going to be basically 1, negative 1, and root 2. Again, we are seeing special right triangle of 45, 45, 90. So this angle is also pi over 4. And finally, the reference angle is pi over 4. And the original angle is going to be from here to here, which is pi plus pi over 4. So half circle plus pi over 4. 2. Answer number 2 is pi plus pi over 4, which we already got that here, 5 pi over 4. So that's how we solve first problem. So let's go here. In this case, we have cosine negative 1 of 0. Well, I'm going to say cosine is adjacent over hypotenuse. So I can set a denominator of 1 and match top by top and bottom by the bottom. But here's the point. Adjacent is equal to 0. This is not possible. I'm not able to make a triangle that the adjacent side is 0. So I need to think of some other way to solve this problem if I'm not able to make my triangle. Okay, consider on a unit circle, we also have quadrantal angles. So in these cases, our angle is basically on quadrantal angles. That's why we're not able to make the triangles. So I'm going to consider the quadrantal angles. we know that on a unit circle, if we have an angle here, and I find the x and value of this point, then the x value is cosine of this angle, and y value is sine of this angle. So all these angles have coordinates like these on these points. If this is unit circle, the radius is equal to 1. So the coordinate of this point will be 1 and 0, because at this point x value is 1 and y value is 0. On this point, x is 0, y is 1. Here x is negative 1, y is 0. And here x is 0, y is negative 1. So on all these points, the x values are cosine and y values are sine. For example, the angle that is made here is 90 degrees. So cosine of 90 degrees is 0, sine of 90 degrees is 1, and so on for the others. So when I have cosine negative 1 of 0, that means there is an angle that cosine of that angle is equal to 0. So I need to look for an x value which is equal to 0. So one of them is here, and the angle related to this point is pi over 2. So one of the answers is, I'm going to write that here, one of the answers is pi over 2. The other cosine, which is 0, is here. So the angle related to this point is 3 pi over 2. So the other answer is 3 pi over 2. Okay. The same way I can solve this one, sine negative 1 of negative 1. So I might at first try to create the triangle. So sine is opposite over hypotenuse. So I'm going to set the denominator of 1 and match them. That means opposite is 1 or negative 1, and hypotenuse is also 1. And that's impossible. Hypotenuse and the leg of a right triangle cannot be equal to each other. Hypotenuse is always more than their leg. So this is not possible. That means I'm not able to make my triangle. So again, I need to go back and look at unit circle and these points. So where do I see a y value equal to negative 1? Because this means sine of an angle is equal to negative 1. And we know that sine is a y value on the unit circle. Where do we see that? Here. So the angle is 3 pi over 2. And in this case, we have only one answer. Now let's work on this example. Tangents. Tangent is opposite over adjacent. So I'm going to make a denominator of 1 here and match these. So opposite is 1, adjacent is 1. This is possible, like the two legs can be 1 and 1. This is okay. So I'm able to make a triangle here. So tangent is a positive value based on what we have learned here. It's going to be either on the first quadrant or the third one. So one of the angles is here on the first quadrant. Here's my reference angle, the right triangle here. Opposite side is 1 and adjacent is also 1. If I use the Pythagorean theorem, I'm going to find this side as root 2. Now I see 45, 45, 90 triangle. So this side is opposite 1 is 45 or pi over 4 radians. So I found my reference angle. Now my first answer is basically pi over 4, because if the reference angle is here, the original angle is also going to be the same thing. So the first answer is pi over 4. The next one, so we said tangent is also positive in the third quadrant here. This is my reference angle, right triangle. Ratio of the sides, opposite is 1, adjacent is 1. In this case, both of them are negative, because this is on left side, this is below the x-axis. Pythagorean theorem gives me this side as radical 2. Once again, I see 45, 45, 90 triangle, so this is pi over 4. Now, if this is my reference angle, the original angle is going to be this, pi plus pi over 4. So the other answer is pi plus pi over 4, which is equal to 5 pi over 4. So these are the two answers that we have here. Now, in the next video, we're going to work on general solutions. I'm going to stop here and start the next video in a few minutes.